This is 13.2 polynomial long division because regular division just wasn't hard enough. And I do mention regular long division because polynomial long division is extremely similar to regular long division, which is where you divide numbers by hand in a way that looks kind of similar to this, only it's just numbers and not x's. So first of all, I'm given a question like this one right here. This trinomial is being divided by that binomial right there. And so I'm going to set this up like regular long division. So I'm going to put the x minus 3 on this side over here, the division symbol here. And then this 7x squared minus 23x plus 6, I'm putting that inside, just like you would if this was regular long division. You're going to see a lot of similar steps. Now, rather than writing out all the steps like how this gets done, I really think the best way to learn from this is to just listen and watch the example. So please make sure you write every step down that we do here and really pay attention to the steps that we do and listen to it. So the main thing with each time you go at this is you're going to check to see how many times is this, just the x, I don't care about the minus 3, how many times just this x go into the 7x squared. That's the only thing I want to consider to start. So what do I have to multiply x by to make 7x squared? Well, I'd multiply it by 7 to make it a 7x. But then I need to multiply it times an x to make it an x squared. So let's just double check. 7x times x is 7x squared. But I need to multiply this also times the negative 3. 7x times negative 3 is negative 21x. Okay? And just like in regular long division, after you multiplied, then you would subtract the result from the top part. So I'm subtracting this whole thing. Here is where it gets tricky. So the good news is this 7x squared is going to just straight up cancel. That's why we chose this 7x in the beginning, because it was going to make this 7x squared part cancel. But now where it gets tricky is with this minus 21x. You can very easily get lost on your signs here. The reason is we are still subtracting this whole thing, which means because I'm subtracting, and that's a negative sign, negative signs change your signs here in the middle. So then while this looks like minus 21x normally, I'm actually subtracting that amount. So as I go through these, this second term here, I just need to always think of it as the opposite sign. Think of this as the opposite sign here. And again, that has to do with the fact that I'm minusing this amount, which minusing that amount changes its sign. So now I'm going to combine positive 21x with negative 23x, which gives me a negative 2x. Okay. As long as you can keep track of your signs pretty well on that part, then this won't be as hard. But that's the mistake people tend to make on this. Okay, now just like in regular long division, you've done your subtraction step. Now you bring down the next number. So this plus 6, I'm going to bring down, and now I'm going to repeat the whole thing over again. X multiplied times what is negative 2x? Well, x times negative 2 is negative 2x. So I multiply that times that negative 2 times both of these. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. And now I'm going to subtract these things, which it always means that you'll always cancel these first ones unless you did it wrong. Okay, these things always cancel. That's the reason why we're choosing the number up top. But now we have to subtract these, which means I need to think of this not as a plus 6, but as an opposite sign, a minus 6. Well, 6 minus 6 is 0. Okay, and since there's nothing more to bring down and there's no remainder, this is it. This is done. So that means that 7x minus 2 is the answer that you get when you divide those two polynomials. In case you're wondering what is the purpose of all of this, the reason why we will be using polynomial long division is it's used for factoring. It can make big complicated things possible to factor. The only catch is you have to be given one of these terms, one of these factors right here. You have to be given that. As long as you're given that, then you can do the process. Okay, so we're just going to streamline this process, showing it over and over again, and we're going to have a couple of weird cases in these examples. Really, the whole idea is we just want to understand by example how this works. So starting again, x times what is x cubed? x squared. Again, you should really write down every step of this that I do. So now the next thing is multiply x squared times both of these, which is x cubed plus 2x squared. And then subtract them. Well, x cubes cancel, that was the point. And I have to think of this as minus 2x squared. Well, 2x squared minus 2x squared also happens to cancel. That's a weird thing. I have none of that left. Well, then that means I need to bring down, of course I bring down the minus x anyway, but that means I'm also going to bring down the next thing, because I need to have two things here. So then now, I'll repeat the process. X times what is negative x? X times negative 1 is negative x. So I multiply, and of course that's my negative x. Negative 1 times 2 is negative 2. Subtract all this, the x's cancel, and negative 2 plus 2, opposite sign, they cancel as well, leaving me with no remainder, which is great. That means that just this is my answer. There's no remainder. You do have to do something special if there's a remainder, and we're going to see that with this one. First of all, x times what is x to the fourth? X cubed times x is x to the fourth, so I multiply that out. There's my x to the fourth minus 4x cubed, because x cubed times 4 is just minus 4x cubed. Okay, these cancel. Remember, I need to think of this minus 4x cubed actually as the opposite sign, because I'm subtracting it, which means I'm actually adding 4x cubed. Negative 3 plus 4 is just positive 1. That's positive 1x cubed. And now normally I bring down the next term, but the next term is just an x. So here's the thing. The next term I'm expecting to bring down is an x squared. I don't have an x squared term. So when that happens, I'm just going to write plus 0x squared. Because it does need to be, if I'm going in order here, if you're missing an x squared or an x cubed or something like that, and you're having to bring something down, you do have to bring down 0x squared, because it's missing. There is 0x squared there. And you'll see why when we go to multiply here, because I need to focus on x times what is x cubed. X times x squared is x cubed. So there's my x cubed. And here, x squared times negative 4 is negative 4x squared. Well, that's the reason why I had to bring down a 0x squared, because I can only combine negative 4x squared with another x squared. So that's why I didn't bring down the minus 7x just yet. So there's kind of an oddball thing that can happen, is sometimes you might have to make a 0x squared or a 0x or whatever the case may be. Well, now the x cubes cancel, and I think of the minus 4x squared actually as plus 4x squared. 0 plus 4 is just 4x squared. Now I can bring down the minus 7x, because that's the next thing in line. And, okay, x times 4x would be 4x squared. So I multiply that out. 4x squared, 4x times negative 4 is negative 16x. Subtract this whole thing. The 4x squareds cancel. I have to think of this actually as a plus 16x. And negative 7 plus 16 is 9x, positive 9x. Okay, and then I bring down the minus 14. X times 9 would be 9x. So I multiply that out. That's 9x. 9 times negative 4 is negative 36. And then I subtract these things. Well, the 9x's cancel. I'm actually adding 36 because it's the opposite sign. And 36 and negative 14 make, what is that, 22, I think? Yep, 22 plus, yeah, that's right. So, but that's it. That's where I stop. There's nothing more to bring down. That means I have a remainder this time. Here's what you do with a remainder. So you take that number, which is 22. I'm going to add it, plus 22, over this thing that I'm dividing by, the x minus 4. Okay. So anytime you work through this and there is a remainder, then the remainder goes on top of whatever you divided by, the x minus 4. And I just add that on to the end. Or subtract, I guess, if it was negative. But this is positive, so there you go. All right, last example. I realize we're going a little over 10 minutes here. We'll do this quickly. 3x times 2x would be 6x squared. Okay, 6x squared. 2x times negative 5 is negative 10x. Those cancel. Negative 7 plus 10 is 3x. 3x times 1 is 3x, so I just put a plus 1 up top there, and I multiply 1 times those. Oh wait, bring down the minus 5, almost forgot that. Yeah, so I brought down the minus 5, and 1 times 3x is 3x, okay? So 1 times negative 5 is negative 5. Those cancel and those cancel, so there's no remainder. That means that that was the answer. All right. Definitely go back and make sure you took all the notes down, you wrote down all the examples, and you really listened to the steps. See you tomorrow.